Welcome back to another episode of From the Luthier's Workbench. In today's episode, I'm going to be covering part 13 of my oak kitchen tabletop guitar build. And I had hoped to finish all the wiring for this guitar in this episode. However, I've run into a little bit of a situation, and I know it's a situation that many of you out there watching will understand, and it's something that's affected all of us. But due to the global situation that we currently find ourselves in, going back to 2019, I run into a little bit of a problem sourcing and receiving some of the parts and materials that I use to build my guitars. And normally when I build a guitar, before I start to cut, carve, and sand, I like to have all the components, all the materials, everything that's going to go into that guitar on hand before I start the work. And the reason for that is because I've learned the hard way over years of experience building lots of guitars that sometimes the specifications that a manufacturer will provide for the parts you're going to use don't always match what they send you. And when that happens, you can run into a problem with components fitting properly in such a way that the guitar will function as expected. And that can be really frustrating, and it can be expensive, and it certainly doesn't make customers happy. At any rate, as I was building this guitar, there was one component critical to the wiring that hasn't arrived yet, and that's the switch which will select the pickups. It's still out there in transit. I've been following the tracking number every day, and it's out there, and it's slowly making its way here. So hopefully I'll have it in hand and I'll be able to get the wiring done for the next episode, part 14. So for this episode, I thought what I would do is talk a little bit more in detail about the wiring scenario I'm going to use for this guitar, because as you'll see, this is going to be kind of interesting. So let me bring you in a little bit closer. So let's talk about the pickups. As you can see, I'm using a humbucker single coil configuration. And these are pickups that I made myself using my eGuitarPlan CNC pickup winder, which is still currently in development and will hopefully be done soon. At any rate, the humbucker features two coils that are wound with 5,000 turns each of 43 gauge wire. Both are wound clockwise. They're wired together in series, and they feature a fully charged Alnico 5 magnet. So it's a pretty strong pickup. The two single coils are pretty much your typical Strat style single coil. One has 10,000 turns of 42 gauge wire. The other the neck pickup has 8,000 turns of 42 gauge wire. And one of them is wound clockwise, the other is wound counterclockwise. One has the south pole facing up, the other has the north pole facing up, and both are featuring Alnico 5 slugs, which are fully charged. So that's the idea here as far as my pickups. And originally, when I started looking at this design for the guitar, my thought was to go with the most brutally simple control scenario that I could conceive, and that was, or it was going to involve using just a simple three-way toggle switch. In position 1, you would select the humbucker, position 2 would be the middle, and then position 3 would be the neck. However, that doesn't give you the option of selecting, a combination like the bridge and the middle, or the bridge and the neck, or all three of them. And the more I thought about it, the more I realized, well, that's really what I've got to do for, to keep a guitar player satisfied with as many tonal options as possible. So typically what you would do with a humbucker single coil pickup configuration is that you would use a lever switch. And you can get 4-way, 5-way, I think 6-way lever switches. And it really just depends on the options that you want to provide. Well, I decided with this guitar that I was going to do something completely different. I've decided for a selector switch, I'm going to use a 6-way 4-pole rotary switch. This guitar project is a good example of why you want to have all your components on hand before you start to build the guitar itself, especially if you're going to be using some components that you've never used before. And in this case, since I'm going to be using the 6-way 4-pole rotary selector switch, I had to really be concerned about the height of that switch because it is considerably taller than most other types of selector switches. Unfortunately, because of the shipping problems that we've been experiencing over the last couple of years, I'm still waiting for that switch. And as a result, in order to proceed with this build, I had to rely on the manufacturer's specification for that switch's overall height. And what I was thinking about as I considered that dimension was that a lot of folks who purchase that switch for their guitars are probably going to be mounting it into a pickguard, which is then mounted on the top of the body. In this case, however, I'm mounting the switch inside the body and it'll mount directly to the top. So that, along with the fact that the control cavity cover is going to be recessed into the body, I have to be conscientious of the amount of space between the back of the switch and the bottom of the control cavity, especially since with this type of switch, there's going to be a lot of wiring connections, and I don't want there to be any interference when trying to attach the control cavity cover. I don't want it to run into those wires. So I had to kind of gamble a little bit, and the solution that I kind of came up with is more of a, let's hope this works, and I think it will. Now, as you can see, this guitar it's similar to a single cutaway Telecaster style body shape. It's a little different, but if you look at the dimensions of an American Standard Telecaster, the body thickness is about 1.75 inches thick. This guitar is about 1.9 inches thick. And the reason for that is when I cut up the tabletop that I used to make the blank for this body, the pieces were just a hair under an inch thick. So by sandwiching the two pieces together to form the blank, I ended up with a blank that was 1.9 inches thick. And I could have easily planed that down to the 1.75 inches that most folks expect with a Telecaster style body shape. However, I knew that since I was going to be using this taller selector switch, it made sense just to leave it as is. After all, 1.9 inches is only just a hair over 1/8 of an inch thicker than your typical Telecaster body shape. So I decided just to leave it at that thickness. And so that's one of the reasons why this body is a little bit thicker than what you would normally expect. And remember, I chambered out the inside of the whole thing. So weight-wise, it's not that offensive. It's pretty close to what you would expect a Telecaster to weigh. And what I am going to be doing now is explaining how the controls will fit in here and some of my thoughts about how this whole control scenario is going to play out. So this is the inside of the control cavity at the moment, and here you can see the different wires from the pickups. These two wires here are coming from the single coils, and what I use when I wire my single coils is 2-conductor shielded wiring. So you have a positive wire here and then a negative wire here, and those two are insulated, wrapped in foil, and coming into contact the entire length of the foil is a bare strand of wire which is soldered to ground, and that in turn shields the entire length of the wire. Because remember, wire is the real culprit here when it comes to noise in a guitar. Wire can act like an antenna to really draw in 60 cycle hum interference. And then for the humbucker, I'm just using typical 4-conductor shielded wire. And I have these two wires are connected together, which means the coils in the humbucker are wired together in series. Then I have my positive wire here, and then my negative wire with the ground wire soldered to it. And this will be soldered to the switch, and this will be soldered to a ground connection on the back of one of the pots. Then I have one last wire here, and this is the grounding wire that comes in from the bridge. Now for the control scenario, what I'm going to be using is a master volume, of course the 6-way 4-pole switch in the center, and then a master tone knob here at the back. And for the potentiometers, I'm using Bourne's 500K audio taper pots. I prefer audio taper. I just like the way it sounds. I know some folks like linear, but my feeling is if you buy this guitar and decide, oh, I don't like that taper, you can always just swap out the pot for a linear taper pot. And then you're probably wondering if I'm going to be shielding this cavity with copper foil. And for this one, no, I'm not. And the reason is because I've been doing some testing lately, and I've come to the conclusion that the main culprit when it comes to noise, as I said before, is the wiring. It acts like an antenna. Well, if your wiring is shielded and that shielding is grounded properly, you're not going to have that issue. So when it comes to the positive connections between my different components, what I'm using is single conductor shielded wiring. So I've got my single conductor core, which is insulated, and that's wrapped with strands of bare wire. And when this is soldered to ground, the entire length of the wire is shielded from 60 cycle hum. So I would just solder this into one component, then I would solder the shielding to ground, then the other end is shielded to the, or is soldered to the other component, but then I clip off this stranded wire here because you only need to connect your shielding to one end of the ground. If you were to connect both ends to ground, you'd end up with a ground loop, and that actually increases the amount of noise. So that's something you need to avoid. You know, if you're curious about that subject, Google ground loops. Although I think I'm going to talk about that in a future Luthier Quick Tips about one of the reasons why when you shield a guitar with copper foil, it ends up sounding noisier than it did without. That's a fairly common problem. At any rate, this is what I'll be using for all my positive connections. All the ground jumpers that will be installed, they don't need to be shielded because they're grounded, so that I don't have to worry about. And of course, I'll be using a Switchcraft mono jack, which will be attached to a rectangular Les Paul style jack plate, and that'll be screwed onto the side of the body here. Well, hopefully in the next episode, I'll be able to actually start soldering this wiring together. And I've decided I'm going to do something a little bit different. I've decided to outsource the design of the wiring schematic that I plan to follow for this. You know, a lot of us, when we go to wire guitars, will go on the internet and do a search for different guitar wiring schematics, and then we'll follow those. Well, normally when I wire up a guitar, I just follow my own knowledge of guitar wiring in order to wire up whatever scenario I'm trying to achieve. However, in this case, since I'm using a 6-way 4-pole switch, I thought it'd be kind of fun to outsource the wiring schematic to a company which specializes in designing custom wiring schematics for guitar builders. They also sell the parts for those schematics. So I've been in contact with this company, and I had them create a wiring schematic for me. And in the next episode, as I begin to solder this up, we'll see how well that schematic works and whether it's accurate or not. Now, I've already seen the schematic, and based on my knowledge of wiring, I don't see any issues, but let's see what happens. So until the next episode, as always, take care, stay safe, give this video a thumbs up, hit the subscribe button if you like guitar building videos and don't subscribe to this channel. And until the next episode, take care, stay safe, and I'll see you soon.